Hello, welcome back. This is lesson 5 in our Unit 3A unit. Today's lesson is called Lewis dot structures for ionic compounds. So in the last video, we talked about how to name ionic compounds with these transition metals that had those multiple oxidation states. So that's where those Roman numerals came into play. So we went from name to formula, formula to name. And so today we're going to kind of use that a little bit. And now that if you give you a formula of a compound, now we're going to ask you to draw the dot structure of it. So that is why it's important that you know how to go from name to formula and formula to name. Okay, so quick review. Looking at this picture, what is happening? So explain in terms of valence electrons what is going on and the type of bond that is forming. So what you should notice is that sodium has that one valence electron. Chlorine has a little empty spot. So chlorine is a bully and comes over to sodium and grabs its electron and steals it. So chlorine has an extra electron and has that minus charge because that means it gained one electron. Now sodium has that positive charge. Again, positive means you lost because there is an invisible one. You lost one electron, and so that's why sodium is positive. Now, positives and negatives stick together, and that is why, or that is where, rather, the ionic bond comes into play. So this is an ionic bond, and the electrons, so ionic bond, and electrons are transferred. Okay, so just a quick review for dot diagrams for ions. So this is super, super important. If you don't know how to do ion dot diagrams, then you will be lost the entire time. So again, for metals, you're drawing no dots. You have those brackets. You have a plus, which shows the electrons were lost, and that number tells you how many electrons were lost. And for nonmetals, you have all 8 dots. You have a negative sign, which means electrons were gained, and the number of electrons that were gained. The chemical formula tells us the ratio of elements to elements. So if we're looking at NaCl, for example, there's no numbers, so we can assume that it is 1. So that means there's 1 Na for 1 Cl. For every 1 sodium, you need 1 chlorine. If we look at MgCl2, we have 1 Mg and 2 Cls. That means for every 1 magnesium, you need 2 chlorines. Again, those subscripts, the little bottom numbers, tell you how many of those elements are in that compound. And again, once you know the formula, you know how many of each thing you should be drawing in your structure. So let's jump into an example. We're going to look at magnesium fluoride. So our first step should be, well, let's figure out what the formula is. So magnesium has that +2 charge, and fluorine has a -1 charge. So if you crisscross like that, you get Mg with the 1 from fluorine. You get fluorine with the 2 from magnesium. And again, we can simplify that and just write MgF2. So that would be our formula. And what that tells us, well, you tell me, how many magnesiums are in this formula? So there should be 1 magnesium. And how many fluorines are there? There should be 2 fluorines. So now we have to draw the dot diagram for this compound. So one of the things to kind of remember, you want to keep opposite charges near each other and like charges away from each other. So let's look at this. We have 1 magnesium and 2 Fs. That means we have to have 3 dot diagrams kind of combined together to make this compound. So let's start with magnesium. Put magnesium in the middle. Again, magnesium is that metal. That +2 means it's lost 2 electrons. So you draw nothing but that +2 charge. Okay, now we have to draw the fluorines. So we have 2 of them. Let's just draw one of them right here. And you always want to try to keep it as simple as you can first. So fluorine has that -1 charge, which means it gained an electron. So 1, 2, 3, 4, 5, 6, 7, 8. So fluorine has those 8. It has that bracket and that -1 charge. So what this shows right now, we're not done because you only have one of those fluorines. So if we even color code this a little bit, one of those electrons was stolen from magnesium. But we know magnesium is going to lose 2 of them. And we know that we have 2 fluorines in our compound, so we need another one. And so the only place we can put it, again, you want to make sure your like charges are as far away as you can, but that also the opposite charges are near each other. The farthest you can get away from this F is on that side. So again, you draw your 8 dots, just like that -1 charge, like that. Now here is your dot structure for magnesium fluoride, and you are done. So you have your positive next to your negative, you have your positive next to this negative, but your negatives are as far away from each other as possible. That is it. Okay, so let's do another example. This one we have potassium iodide. So potassium is K with that +1 charge. Iodine is I with that minus charge. Again, when you crisscross, you get K1, I1. And again, all you need to do is just write Ki. So that is what the compound we're going to draw is. So how many Ks do we have? Good, we should have 1 K. And then how many I's should we draw? Good, again, 1. So let's start with our K. K, we said has that +1 charge. And again, what that +1 charge means is that it lost its electron. So all you have to do is draw the K. Then if we're looking at iodine, iodine normally has 7 valence electrons. But what happened is that it stole one from potassium. So now that's why potassium has that +1 charge. Iodine now gained an extra one. And so when you gain an electron, you have that negative charge. And this is your dot diagram for potassium iodide. So one thing I do want to point out here is that sometimes if you see Regents questions, they will have it like this. Sometimes the Regents does not put brackets around the positive ion. That's technically correct. I personally just like putting brackets around all the ions just to keep everything kind of neat, but this is the same thing as that. So I want you to get in the habit of using the brackets, but if you see a Regents question where the positive ion does not have brackets, that is okay. But I'm going to continue using the brackets because I like the way that works better. Okay, next we have aluminum fluoride. Aluminum has a +3 charge. Fluorine has that -1 charge. So when you crisscross, you get Al1F3, which can be simplified to AlF3. Okay, so this is the compound we're drawing. Now, how many aluminums are going to be in our picture? Again, 1 aluminum. And how many F's are going to be in our picture? Great, 3 F's. So, again, let's just start by drawing our aluminum. Aluminum is going to have that +3 charge because it lost those electrons. And again, I like using those brackets on the positive ions. So now let's draw our fluorines. So let's draw a fluorine here. 1, 2, 3, 4, 5, 6, 7. Again, this 8th one came from the aluminum. So this is your -1 charge. And so if we draw another fluorine, 1, 2, 3, 4, 5, 6, 7, with that extra one from aluminum, you have, again, that. Now we've drawn 2 fluorines. And then if you have that third one, you can kind of just put it on the bottom, and then just do 1, 2, 3, 4, 5, 6, 7. Again, that last one from aluminum, and your negative charge. So you have 3 -1 charges, 1 +3 charge. Your compound is neutral. And again, if we're looking at it, aluminum is going to lose those 3 electrons. Fluorine only can gain 1 electron, so that's why you need 3 fluorines to gain all of those electrons. But this is your final picture. Again, not the most difficult thing in the world, but you have to know how to draw ions. Okay, last example in this video is barium chloride. Barium is Ba with the +2 charge. Chloride is again chlorine with that -1 charge. Crisscross, you get Ba1Cl2, which again you can simplify to BaCl2. So we have, how many bariums do we have? We should have 1. And then how many chlorines? Again, 2. So you have 1 barium, 2 chlorines. So let's start by drawing our barium. Our barium is right there. Again, that +2 charge, no dots because it lost those 2 electrons. So again, barium normally has 2 of them, but they're going to be lost, and that's where that +2 charge comes from. And now we have to draw 2 chlorines. So if you draw one of them, again, chlorine normally has 7 valence electrons, but it noticed barium and was like, hey, I'm going to steal your electron, so I have my perfect 8. And so chlorine has that extra electron with that -1 charge. But again, we know we have to draw 2 chlorines because 1, the formula tells us, and 2, this isn't neutral yet. When you have your other chlorine drawn, and then you have that, when you have your -1 charge, that extra electron from barium, that is done. So again, this is your final picture. Your positive is near your negative is near your positive, but your like charges are as far away as possible from each other. Again, that is it. So drawing dot diagrams for these structures really just come down to drawing the ions and then just putting positives near negatives and negatives near positives. So we are going to practice this more in class together. Hopefully this helps. In the next Edpuzzle video, we're going to cover properties of ionic compounds. That is it. Bye.